Hey everybody, this is Games Plus James, and welcome back to our Unity 3D platformer tutorial series. Now, in our first video, we set up the whole scene of all the various things that we're going to have our player navigate around, and in this episode, we're going to take a look at moving the player himself around through the world. And to do this, we're going to take a look at two different ways of handling movement in Unity. First way we're going to look at is using the rigid body. Now, we saw in our previous video, if I go to my player here, we added a rigid body to the player object, and if I drag him up in the air here, for example, and we hit play, he'll fall down to the ground just the way we want him to, which is perfectly fine. That's grand. I'm going to put this back to the starting position. And that's all fine and grand, but there's a couple of issues that just using the rigid body could lead to. So we're also going to look at using the built-in Unity character controller to control our movement. And then we'll discuss which is better and whether to use the rigid body or the character controller as we go forward in the series. So first of all, we're going to take a look at doing movement using the rigid body method. And first of all, to start off with, we're going to need to create a script that will allow us to move the player around in the world. So let's go to our assets folder here. I'm going to right click on assets. We're going to create a new folder that we're going to call scripts. I have saved the scene in between videos here, so just to demonstrate, if you haven't saved a scene here in Unity before, I've obviously saved this one as test, but all you have to do is go to File, Save Scene, or Save Scene As, and then choose your name to save the scene as. We're going to go with test here, and normally what I would do is go create a new folder that we'll call Scenes, go into there, and we'll save test.unity, or you can just type test and it'll automatically become a .unity file. We'll say test and save that, and if we look in our scenes folder, we can see there. But we're going to go back to creating a script. So we're going to create a C# script, which is what we're going to use for all our coding here in Unity. We're going to go create and then C# script, and then we're going to call the script player controller. We want to make sure that we spell it without any spaces in the middle, or else the script won't be picked up properly by Unity. So we need to make sure there's no spaces. And what we want to do is capitalize the first letter of every word. You don't have to do that, but it's sort of a convention in coding in general. And that way, if we call it that with a capital P and a capital C, when we go to add it to the player, and to add it to the player, there's a couple of different ways of doing it. We could click and drag this onto the player, or we could go to the player here, go to add component, and start typing in player. And because we used capital letters to kind of mark the beginning of new words, Unity knows to automatically put a space in when it's showing it to us, so that it makes it a bit easier to read things going forward. So we're going to add that player controller to our player. It's important when you create a script that's going to do something to try and remember to actually attach it to the object that you're wanting to use it on. So I'm going to open this player controller script. I'm going to open this up in Visual Studio here, which is one of the two default options in Unity at the moment. You might have it set up to open in MonoDevelop or Visual Studio. It's all down to a personal preference. I prefer Visual Studio, but it all works the exact same in the end. So what we want to do is, first of all, up here, we have these built-in methods that Unity uses by default. If you haven't worked in Unity before, these are kind of default things that allow us to know when things will happen within the game. So we have a start function here, which happens as soon as either the game starts running, if the object is within the world. So as soon as we load into a scene or start our game in an active scene, anything within this function will happen straight away. Or else, if an object hasn't been activated in the world, not activated, but an object hasn't been created in the world, and we create a new object within the world, as soon as that appears within the game, it'll run this little start function. So any activities or functions that we put within these two open and close curly brackets, they'll take place as soon as they possibly can. Then we have the update loop here, which is the other default kind of starter function that you have in Unity. And update happens every single frame of the game. So every time there's an update to the screen and we're, say, moving the character or anything like that, it'll all happen within the update loop here. So if we want to move our player around within the world, there's a couple of things we're going to need to do. We're going to need to create some variables. And variables essentially are just, they can be, say, numbers or words or game objects within the world or references to other scripts or anything like that. Now what we want to do is we want to create a speed value for our player. So we're going to say public, and public just means that we're able to edit this value within Unity. We're going to say float. A float is a type of number. There's two main types of numbers that you'll use in general in Unity. A float is any number that has a decimal value, so 5.7, 139.367, whatever. The other type of number is an int value, and an int value is only a whole number. So 1, 2, 3, 4, 5, 6, 120, 5009, whatever numbers like that, but no decimal places within an int. But we're going to use a float value for our move speed. And again, we typed move speed in a specific way. We make sure we don't put any spaces within the word. And we could capitalize the first letter, much like we did with scripts. But again, it's kind of a naming convention within Unity or within coding in general, is your variables should start with a small letter, and then every new word has a capital letter as you go forward. So if I was just to save this script now, sorry, one more extra thing. If you haven't done any scripting within Unity before, you need to make sure that you end any line that does something with a semicolon. So what this line here does is it creates this variable, which is a float variable, and it's public, which means we can edit it within the Unity editor. Actually, and speaking of public, I'm going to create another variable just below that we're going to call private, and we'll have it be another float, and we'll just call it extra number. It doesn't matter, we're going to get rid of this in a second. Just to demonstrate that what a private value means is that you can't edit it within Unity. You can't see it when you're in the editor at all, but it could be a number that you only want, that say you want to use it within the script, but you don't ever want to change this number. You'll assign it in here, say somewhere, and then you'll do something with it. But you don't need to be able to edit the value yourself. So just as a demonstration of this, I'm going to save this by hitting Control and S. Then we're going to go back into Unity. You'll see a little spinning wheel. That's kind of has gone a bit quickly there, but there's a little spinning icon here. Whenever you go back into Unity after saving your scripts, it means it's compiling for Unity to be able to use the script. So if we go to our player, we attach the player controller script to our player, and then we can see we have the move speed variable down here. Let's set this to, say, 10. That'll be a reasonable enough number. So that's our move speed down here. But you can see we don't have the other number that we created, our extra number. We don't have that down here because it's a private variable, so we can't see it. Okay, so I'm going to delete that because we're not going to use that. So as we said, we're going to look at moving our player around using the Rigidbody method. And to be able to do that, we need to be able to access the Rigidbody itself. So we're going to type in here public Rigidbody 2D. Oh, sorry, not 2D, sorry. Just a Rigidbody. Because we have over here just a Rigidbody, which is a component that's attached to our player. So we want to be able to access this. So we're going to need to create a reference name to it. So we're going to just call it DRB for the Rigidbody. Now, there's a couple of different ways we can actually get this so that Unity will know how to use this Rigidbody. So if I were to save this and go back into Unity, once we let it compile, we see we have an empty space here that's looking for a Rigidbody. So what we could do is click and drag on the Rigidbody here and drop that in there. You see it turns blue, it means we can drop it in place. What we could also do is click and drag the player from in here, because this is the player that we're already using, but this is an object that has a Rigidbody attached to it, so we could drag that in there, just like that. Or the third way to do it is, we know that as soon as the player starts moving within the game, we want to be able to access that Rigidbody. So how could we, using the script, do that straight away? Well, as we discussed before, we can use the start function, because the start function happens straight away. So what we could do here is say, okay, the Rigidbody reference that we created up here, that should be capital RB. We want to set that to be equal to, we're going to call a function called get component, and then we put a sharp bracket like this, and within these little pair of sharp brackets here, we're going to type rigid body. So what we're saying is we want to get a component of type rigid body, and get component is another default function built into Unity that we can just take advantage of. And what this will do, we got a little red line underneath it because we haven't finished it just yet, but what this will do is say, okay, get any component that is attached to the same object that our player controller script does, is, and get any component that is of the type rigid body. So it'll go, okay, as soon as the game starts, look on the object, do we have any components called rigid body? Yes, we do. Okay, slot that in here to be equal to what our rigid body is. And at the end here as well, I know we discussed that we have to add a semicolon like that, but there's one extra thing here. Because this is a function, functions behave a little bit differently. They're not just a reference like these things here. Whenever a function is going to do something, we want to say, oh, didn't mean to do that because I was highlighted there. That was the wrong thing. But we want to say here, just after the sharp brackets, we're just going to put an open and a closed bracket. And basically, that's how you call the function. Sometimes, and we'll encounter it in just a few moments, within these brackets, we'll want to do specific things in here. But right now, all we want to say is, okay, just find the rigid body, and that's all we want that to do. So let's see that in action. We're going to save this, go back in here to Unity, let that compile, hit the play button, and you'll see as soon as our game starts playing, the rigid body in the slot here now knows it's the rigid body attached to the player object. So if we click on it, you can see it highlights the player object over here. So perfect. It's found the rigid body just the way we want it to. So let's start applying the move speed that we've added to the player. We're going to do this in our update loop here, and we're going to take advantage of the built-in input system that's built into Unity. So how do we move around within Unity and using the rigid body? We're going to use the velocity of the player. So basically we're going to set it so that our player has a certain velocity whenever we press any directional buttons. So we're going to say on the rigid body, we're going to say the rigid body dot velocity. So what we're doing there is we're accessing our rigid body object, and within the rigid body there is a value here called velocity, and our velocity is our kind of movement within the X, Y and Z axes. So forward and back, left and right, and up and down. So what we want to do is set our velocity to be equal to a new vector tree. So a vector tree is an object that has three values, an X, a Y and a Z value. So we want to be able to set our X, Y and Z speed within the game. So our first value will be our X value. So in Unity, in the three-dimensional space, if we go back in here and take a look at our little dude here, we have the X-axis here, which is on this red line, and if we want to move forward in the X-axis, that'll bring us back and forward like that. If we want to change our value on the Y-axis, that'll bring us up and down in the air like this, and then finally on the Z-axis, it'll bring us kind of left and right like this, or depending on which way we look at things. This is forward and back. If we're looking at the camera there, we can see we're moving away forward and back like that, and say left and right is on this axis here. Okay, let's just move him back so he's touching the ground again. Let's go back in here. So what we want to do is set what our value is on the X-axis. So we'll just look back here again. Our X-axis is this movement here. So if we're looking at the camera, let's say that should be our left and right movement within the world. So back in here, our left and right is essentially our horizontal input within the world. And what we can use is Unity's built-in system, which is we can type input dot get axis. So we want to use the x-axis, and using the input built into Unity, what we're going to actually use is the horizontal axis. So I'm just going to open a bracket, and as we discussed before, sometimes within these brackets we want to put something in there to be able to tell the getAxis function which axis do we want to actually do something with. So the axis we want to use is the horizontal axis, and we put it within these quotation marks so that Unity knows that this is a thing called a string, which is just a collection of characters or a word or maybe a sentence, but for our purposes we're using horizontal. Now, just to demonstrate what is the horizontal axis here, well, if we go into Unity and then go to Edit, Project Settings and Input, if we drop down these axes here, we can see we've got a whole bunch of input stuff, and this basically controls all the default controls that are built into Unity. If we drop down horizontal here, we can see horizontal by default is set up to be the left and right arrows, and also A and D on the keyboard. We can see down here that vertical is up and down arrows, and our S and W for moving back and forward as well. So they're the kind of WASD controls are moving around with your arrows. If we look down here, we can see horizontal and vertical again, and these are set up by default to work for controllers. So if you have, say, an Xbox controller plugged into your computer, you could use that for a horizontal axis and for the vertical axis. So that way, by default, Unity has it set up so that you can actually straight away use an Xbox controller when you're working on your game here. So we're using the horizontal axis to move us on the x-axis, but we don't want it to just be a case of 0 and 1, which is what a horizontal axis will move between. Well, between 1 and, say, -1. If you're moving to the right, you'll have a value of 1. If you're moving to the left, you'll have a value of -1. But that'll be pretty slow for our character, so we're going to multiply that by our move speed. So we have our move speed, we're going to multiply that by the horizontal input axis, and that's what we're going to use on our x-axis. So now we want to move on to the y-axis, and the way we do that is we put a little comma here, which means we're done dealing with the x value, so let's move on to the y value. If we go back in here and look at our player, we know that the y-axis is what moves us up and down in the air, so we don't want our player to be constantly moving up or anything like that, so we're not going to do anything on the y-axis to do with movement right this second. So we're just going to say leave the y-axis to what it already was, and the way we can say that is look at the rigid body again. So the rigid body, go into the velocity, and we want to get whatever the whatever the dot y value of the velocity already is, we'll just keep that at the same value. We're not going to make any changes to it here. So if you're already, say, falling down through space, we don't want to make any changes to that, so leave it as it is. So finally we have the z-axis, and on the z-axis, well, we know we don't want to move horizontal, we want to move forward and back like this. So let's go ahead, and this time we're going to say input dot get axis, and this time inside the brackets we're going to put vertical like this, and again we're going to multiply that by our move speed. So perfect, that's our z-axis and our x-axis set up to take in whatever input we press, and our y-axis is set up to just stay the way it is for the moment. So that's our new vector being created, and because we've done something on this line here, we want to make sure that we end that line and we know it's actually doing something, so we hit our semicolon at the end there, and then we can hit Control and save, or Control and S to save, go back into Unity, let it compile, and now if I hit play, well, he's falling over a little bit. That's because we didn't change any settings, but we can see our player is moving around through the world. So I'm moving left and right, and I'm moving backwards and forwards. I'm just going to stop this now. We don't want our player to be falling around all over the place like that, so we need to go into our rigid body here, go to constraints, and we're going to freeze the rotation of the player on all the different axes so he doesn't fall over when we drop him down on the ground. So now you can see we can move around and the player stays upright the way he should. So perfect. So that's our player moving around like that. Let's give him one more little bit of control. Let's go back in here. Now, we said we won't make any changes to the y-axis when we're moving around like that. But of course, we really want our player to be able to jump up and down within the air. So let's go back up to our variables up here. And we're going to type a new variable that we're going to call public float jump force. And then here, what we're going to do is do an if statement, which we'll use to check and see if the player is pressing a particular button, which should make him jump. And then we're going to apply the jump force to the player. So here we're going to say if, and the way if statements work is we say if like this, then we put a couple of open and close normal brackets, and then we put an open and close curly bracket like this. And within this first bracket is where we check if something is true. So what we want to do is say, in here we want to check if a button has been pressed. So here we can say if input dot get button down, which is how in Unity we check and see if any button has been pressed. And what we want to do is check the name of a particular button, which will be jump. And we put our quotation marks to start and end that line as well. And the jump variable, if we go back in here to Unity and have a look at our project settings, again, project settings input, and we go and look at jump, and we can see that jump by default is set up to be the spacebar, which is perfect. That's what we want to do. And also on a controller, if we go to jump, it's set up to be joystick button 3, which I think is Y on an Xbox controller. So we go back in here, and what we can do then, now that we know we're able to check and see if we've pressed the button jump, because there's two brackets, an open and close bracket here, we want to make sure that we put another bracket like this, which is the close bracket for the first bracket here, because we need to make sure that we always keep those brackets balanced, or else you're going to have a script that won't work for you at all. And then within our curly brackets here, this is when we actually do something. So here we've checked to see if this is true. And if that's true, so if the player has pressed the spacebar, here we're going to apply the force. So we're going to say, this time, the rigid body dot velocity. Again, we're going to say it's a new vector tree. On the x-axis, we're not concerned with that at all, because we know we're using the input up here to control whether there's any x-axis movement going on. So we're just going to leave this as it already is. We're just going to say the rigid body dot velocity dot x. The value we actually want to change is our y value, and what we're going to do here is just set the jump force value, which is up here, as our new y value, which will make our player shoot up into the air. So we're just going to say jump force like that. And then finally on the z axis, we're just going to leave this also as the rigid body dot velocity dot z like this. Okay, so now we've got the very simple little jump and movement on our player. So we're going to save this and go back into the game. That's compiled, so I can hit play. And now we can move our player around and... oh, we didn't give him a jump force value actually. Hold on, stop this running. Go back to our player. We need to give him a value for his jump force. So let's say 20. And of course you can always play around with these values to whatever feels good for you. So we move our player around. We can jump up in the air. That's probably a little bit too high. Let's go back down to 10. That's still too high. 5. There we go. That'll do for now. So that's enough to let us jump up these steps of the stairs. Oh, like this. Up. We see we've gone off the camera here, but we can still see ourselves in the scene. So we're able to move our player around now using a simple rigid body physics, and we can jump up and down in the air. Now, there is a bit of a limitation to how this rigid body physics works, which is why we're going to take a look at using the character controller as well. So one of the problems with using a rigid body is if, for example, I just run up this little slope here, you can see, oh, our player goes flying off the top. Now, if we were driving a car or anything like that, that would be something that we'd wanted to do. But this is a player in a game, so really when we kind of walk up the top of a slope like that, we want our player to just stick to the ground, not go flying off like up a little ramp or anything like that. When we walk over the side, it's fine for our player to keep their momentum. If they're pressing a direction or anything like that, that's fine. But really, we want our player, when he's walking up a slope, not to go flying off like that. And that's why we're going to take a look in the next episode at moving our player around using the built-in character controller within Unity. So thanks for watching, and I'll be back soon with more Unity 3D platformer tutorial goodness. Goodbye.